Jai Hind all, and today we will discuss about big data, and that is the unit one. In this unit, there is the first unit of the big data. Your subject code is VCS 60061, and today we will discuss about what kind of big data are there, why we are using the big data, and where we use the big data. So first is introduction part, and second one is the types of digital data, and the third one is history of big data innovation, and what kind of big data platforms are available. So what is big data? Big data is basically that is in the size of high. So big data is a collection of data that is huge in volume, yet growing exponentially with time. It is data with so large size and complexity that none of the traditional data management tool can store it or process it efficiently. Big data is also a data, but with huge size. Okay, huge size, it means the static shows that 500 TB, 500 plus terabytes data is show of new data generated, data ingested into the database of social media site, Facebook, Twitter, Instagram, LinkedIn, and so on. So this data is mainly generated in terms of photo, videos, and audios, message exchange, and putting comments are there. So for the analysis point of view, in this diagram, there the data sphere is a number of numbers per second, and these are the email sent number per second. There is a 3 million email are sent, 5 WhatsApp Messenger, Google search, Facebook post, tweets, Snapchat, SMS message, Instagram post. So that these diagrams show how many posts or how many the data is sent from one location to the another. So email send 34000000, WhatsApp 740741, Google search is 68542, and Facebook post is 54977, tweets is 5700, Snapchat 4630, SMS message 4595, and Instagram post is 694. That is the 1 second number per second data. In the daily activity user of the Facebook over the years, if we talked about Facebook daily activity user in 2024, 2.11, 2.11, 2.00, 1.93, 1.85, 1.66, 1.52, 1.40, 1.24. Right now, they are around the 2.4 billion Facebook daily activity users are there. So there are basically big data phase 1 structured content period from 1970 to 2000. We are using the RDMMS and data warehousing, extract transfer load, online analytic processing, dashboard and scorecards, and data mining and statistical analysis. So these are the era of the 1970 to 2000. But in the period of 2000 to 2010, that is information retrieval and extraction also, opinion mining, question answering, wave analytics and wave intelligence, social media analytics, social network analysis, or spatial temporal analysis for the temporal data. But right now into the big data phase 3, mobile and the sensor based content, it is location aware also, person centered analysis, context relevant analysis, mobile visualization, human computer interaction. So these are the today's scenarios or type of data also. So the total amount of data in the world was 4.4 zettabyte in 2013. That is set to rise steeply to 44 zettabyte in 2020 and 180 zettabytes in 2025. That is the main issues are there. So if we talked about to unit wise, KB 1000 bytes, a paragraph of the text or document, MB 1 KB, a small novel, GB 1000 MB with 1.5 symphony, like example 1000 GB 1 TB equal to all the X-ray in the large hospital, 1 PB is equals to half the content of all US academic research library, 1 EB about 1/5 of the world people have ever spoken, 1 GB is 1000 exabyte, as much information as their gain of send of all the world which is, and yottabytes is 1000 zettabytes, as much information as the atoms in 7000 human bodies. Okay, so that is, So we have a three type of data in this in today's scenario. Structured data, only 10% of data. So this is the relational database that can be processed, easily accessible, and can be stored in fixed format like financial data, like machine logs, like demographic tables, like Excel sheet. Like semi-structured data, this is hybrid of structured or unstructured data. That is also the 10% data. Example like XML and the JSON data, where we exchange the information, both of them. Unstructured data, that is the most of data is 80% data is unstructured data. So this data is different formats such as document, such as multimedia file, such as image, such as backup file, social media post, audio files, and open-ended customer comments also. So that is the major responsibility to process this kind of data. So structured data versus unstructured data can be displayed in raw column and relational database like in the table format. Number, data and string, estimated 20% of the enterprise's data, require less storage, easier to manage and protect the legacy solution. But unstructured data cannot be displayed in row and column like video, like audio, like word processing files. 80% of enterprises data is like this, require more storage and more difficult to manage and protect with legacy solution. So we have a three type of data. We already know that: structured, semi-structured and unstructured. Structured 10%, semi-structured also 10%, and structured 80%. So structured, it means into the raw or column format, just like the Excel sheet. Semi-structured in two format, XML or JSON format, or unstructured any format, that is called the unstructured format. So predefined data models like database, usually text only, easy to search and filter. Example: data, phone number, transaction information. Both structured and unstructured qualities considerably easier to analyze than unstructured data. Example like email, CSV file, JSON files, these are the data. No predefined data models are there, difficult to search through. Okay, usually stored as different type of file. For example, social media, for example, audio files, for example, image files, for example, video files. So like unstructured data, like semi-structured data, or like structured data. There are three different kind of data here. Unstructured data, like there's a something like into the form, into the different form. So university has 5600 students. John number is 1. He is 18-year-old, BSc degree. David number 2. He is 31-year-old, PhD degree. Robert's ID number 3, 51 years, hold same degree as David as PhD degree. So that is unstructured data, but this is semi-structured data into the JSON format. Student ID 1, name John, age 18, degree BSc. David name, age 31, degree PhD at student or university. Like this, ID, name, age or degree. John 18, 18, BSc, David 31, PhD, Robert 51, PhD, Rick 26, MSc, Michael 19 or BSc. So that is the structured data in tabular form. The next is the history of the big data innovation. So the advent of big data analytics was response to the rise of the big data started in the 1919. So very long before the big data was coined, the concept was applied to the dawn of the computer age, when business used large spreadsheet to catch number of find trends. So if we are using the large spreadsheet to find out the trends, what kind of trends of the product marketing. So the large amount of data created in late 1990 and early 2000 was fueled by the new data sources. And the popularity of the mobile device and search engine created more data than any company knew what to do with. Second one is speed was another factor. So the faster the data was made, the more is had to be handled. So in 2005, Gartner explained 3 V's of big data, like variety, volume and velocity. Variety, it means different kind of data. Volume, it means how many size of data, and velocity, what kind of speed of the data. So recent research of IDC project that data generation would grow tenfold worldwide by 2020. So according to this diagram, there is the history of the data. So in 2002, Doug Cutting and Mike Kafrala started working on the nudge, and they are working with a nudge. Google published GFS and MapReduce papers using Doug Cutting and Kafrala. Doug Cutting had DFS and MapReduce support to nudge in 2004. And 2006, Yahoo hired Cutting Hadoop spin out of nudge. 2007, New York Times convert 4 TB of image achieve over 100 EC2s. 2008, if we talked about Facebook launch Hive SQL support for the Hadoop, and also the fastest sort of 1 TB 3.5 million over 910 nodes. In 2009 also Cloudera founded, and 2009 is fastest short of the TB and 62 seconds over 1460 nodes sorted in petabytes in 16.25 hours over 3658 nodes. So Doug Cutting joins Cloudera Hadoop Summits 2009, 750 attendees. So that is the overall 2000 to 2009. That is the era of the big data. So these are the some V's are there. They are the main 3 V's are volume, velocity or variety. These are the 3 main V's, or we can say like the 5 V's also. So volume, it means size of the data. Velocity, the speed at which data is generated. Variety or different type of data like image, like video, like audio, like messages. Veracity, it means the accuracy about the data, how the data is accurate, and value about to useful data from the raw data. Another 5 is also implemented into the big data. Validity, it means data quality, governance, master data, management on massive. Variability, dynamic evolving behavior in data source. Venue, distributed heterogeneous data from multiple platforms. Vocab, data models, semantic that describe data structure, or vastness, confusion over meaning of big data and tools used. So that is the 10 V's which is basically used into the big data. Big data versus data science, factors, big data or data science. So data science it means analyzing the data, or big data is handling the large data. What kind of responsibility? Process use volume of data and generated insight, understand pattern within data and make decision. E-commerce industry, security service, telecommunication, sales, image recognition, advertisement, risk analysis. Hadoop, Spark and Flink, their tools are using in this data science, SAS or Python. So big data refers to storing, managing and processing large volume of data, while data science focus on analyzing and interpreting data to gain insight and make informed decision. So that is the difference between big data and data science. The last topic is introduction to big data platform. So big data platform are comprehensive framework that enable organization to store, process, analyze vast amount of structured as well as unstructured data. So at their core, big data platform are comprehensive ecosystem of the tools, technologies and infrastructure designed to handle the 3 V's of data: volume, velocity and variety. These big data platform empower business to identify trend and optimize operation by leveraging distributed computing, parallel processing, machine learning, deep learning and advanced analytic techniques. So step from starting data injection to store to data processing and visualize the data. So big data analytic platform offer a comprehensive solution for managing and harnessing the power of data into the modern age. So these are the steps of big data platform divided into the following stages: data collection, data storage, data preprocessing, data analytic, data management warehousing, data catalog metadata, data observability or data intelligence. So data injection, data management, ETL, extract, transform or load, and warehousing, and Hadoop system, stream computing, analytic, machine learning. So stream computing, it is using for the real-time processing, way to analyze and process big data in real time to gain current insight to take appropriate decision or to predict new trend in the immediate future. So what is the main need of a big data platform? So to provide user with efficient analytic tool is specially designed for handling massive data set. There is the first need. Second one, data engineer often utilize these platform to aggregate, clean and prepare data for insightful business analysis. Number 3, for the data scientist purpose, on the other hand, leverage this platform to uncover value relationship and pattern within large data set using advanced machine learning algorithm. Furthermore, user have to flexibility to build custom application tailored to their specific use cases, such as calculating customer loyalty in the e-commerce industry, among countless other possibilities. So these are the best big data platform: Apache Hadoop, they are Yahoo, Facebook and Twitter use Apache Hadoop, Apache Spark, Netflix, Uber or Airbnb, Google Cloud, BigQuery, Spotify, Walmart, New York Times, Amazon EMR, Expedia, Lyft, Pfizer, Microsoft, Azure, SD Insight, Starbucks, Boeing, T-Mobile, Cloudera, Dell, Nissan, Comsat, IBM Infosphere, Lenovo, DBS Bank, General Motors, and last Databricks is all platform is using by Nvidia Corporation, Johnson & Johnson and Salesforce. So these are the some component of big data platform: data injection, integration and ETL. It provides these resources to effective data management, effective data warehousing, and just manage data as valuable resources. Stream computing, it means real-time analytics. Big data analytic platform, machine learning, it provides tools and machine learning tool with machine learning operation and features for advanced analysis and machine learning. And after that, data integrate and warehousing, it provides user with features like integrating it from any source with easy. And last to data governance, also provides comprehensive security, data government and data protection solution. So these are the some component. Provide accurate data. So it delivers analytic tools which help to omit any inaccurate data that has not been analyzed. This also allows to business to make the right decision using accurate information. Also, the cloud data warehousing for scalability, it is also using the scalability. When we require the high data, we can scale the data or we reduce the data. So it offers scalable storage capacity also. Data discovery platform for the price optimization. So data analytics with the help of big data platform provide insight to business to customer and business to business enterprises, which help business optimize to price, they charge accordingly. And data observability with the warehousing set, analytic tools and efficient data transformation, it helps reduce the data latency and provide high throughput. So that is the architecture of the extract, transform or load. That is the RDMS folder. We have to extract the data from the folder and transform and load into the data warehousing, or these warehousing also load into the and show into the web pages, and that is API sources. Okay. So difference between OLAP and OLTP. So OLAP is a structured, semi-structured, unstructured data. ETL, extract, transform, load, staging area. Then OLAP is data mart, data warehousing, and report scorecard, dashboard, mobile is using for the reporting visualization purpose. So OLAP, it means online analytic processing, or OLTP, it means online transaction processing. So OLAP system have capability to analyze database information of multiple systems at the current time. The primary goal of OLAP service is data analysis and not data processing. But into the transaction processing, the work administrator, day-to-day transaction, any organization, the main on OLTP is data processing, not data analysis. So this is using for the data analysis, this is using for the data processing. These are the difference between both of them. Definition: it is well known as online database query management system, online database modifying system consisting of historical data, consisting of only operational data. It is using the data warehousing. It uses the DBMS. It is subject oriented, object for data mining, analytic, decision making. It is application oriented. In an OLAP database, table are not normalized. In an OLTP database, table is normalized in 3NF. The data is used in planning, problem solving, and decision making. The data is used to perform day-to-day fundamental operation. For the task purpose, it provides multi-dimensional view of different business model task. It reveals a snapshot of the present business task. It serves the purpose to extract information for analysis and decision making. It serves the purpose to insert, update, and delete information from the database. So volume of data, large amount of data is stored typically in terabyte, petabyte into the OLTP, MB and GB. Queries, relatively amount of data involved in large, very fast, 5% of the data. OLAP database is not often updated as a result. Data integrity is unaffected. The data integrity constraint must be maintained in OLTP database. It's only need backup from time to time compared to OLTP. The backup and recovery process is maintained rigorously. The processing time is lengthy time, is very fast. That is used by CEO, MD or GM. This is used by clerk forex and the manager. Read and really write operation, both read and write with lengthy schedule batch operation. Data is refreshed on the regular basis. The user initiate data update, which are brief and quick. The process is focused on the customer. The process is focused on the market. Design with focus on the subject. Design that is focused on the application. Improve the efficiency of business analysis. Enhance the user productivity. So these are some references using for the big data analytics. And if you have any query, just ask me my mail ID guptapradeep@akgc.ac.in. Thank you.